I am Son Goku. Uh, well, my name's actually Hector Matos. I am an iOS developer for Capital One. A couple of speakers here are also developers for them as well. Major bank in the United States. So what I'll be talking about today is Hipster Swift. I do apologize for the Japanese translations on my slides. I did try my best. Now, you may have seen all of these. You may have seen none of these. Either way, what I'll be talking about today will be a breakdown of what each of these are. And all of these are really neat features in the Swift language that you can take advantage of in your day-to-day work. Personally, I can't tell you how many times that I've seen all of these features and just wanted to give up on ever thinking that I truly knew Swift. And what's worse is that I saw several awesome developers on Twitter using these features as though it were no big deal. To me, it was a pretty big deal. I did not understand it. Every time I looked at it, this is basically how I felt. So maybe what you see here is what you feel after seeing those names in my previous slide. I know when I saw half of these, I definitely felt like Goku was chewing on my head as well. But don't worry, it gets easier, I promise. And hopefully I can shine some light on the situation to help all of you out. Now, the first thing we'll talk about is NoEscape. I see y'all like my translation. At NoEscape was always a very weird thing to look at. The good thing about it is that after you learn it, it's very easy to understand. The first thing to remember, though, before we actually talk about this, is that closures, remember, are first-class citizens in Swift. They can be assigned to a variable. They can be torn down in memory, just like any class instance. Because of this, many of us forget that some of our closures that we pass into functions can be stored off somewhere for later use. Take, for example, the Notification Center's block-based API. The closure that we pass into the using block argument of this function actually gets stored off into a separate array of blocks mapped to a dictionary that uses the notification name that you see up there as the key. This means that we are giving Notification Center the responsibility of deallocating our block for us. After the addObserver function got called, the closure essentially escaped our addObserverForName function. And that's important to remember. It escaped the addObserverForName function. Now, what does that actually mean? It just means that it did not get called before the end of the function scope. So what if we don't want this behavior in our own functions? What if we want to give our caller the peace of mind to know that the closure that they are passing in will get called immediately? This is where NoEscape comes in. As you can see, I have a function here, all right? And you can see NoEscape. At NoEscape is a Swift attribute that you can use to annotate a function's closure parameter. Now, how you create it, obviously, you put NoEscape before the closure name. What we are essentially telling the caller of the train for the fight against Frieza function is that the closure will be called before the end of the function's control flow. So, as you can see here, I've tried my absolute best to make the preparations closure that you see up there escape the control flow of the train for the fight against Frieza function. Luckily for us, the compiler wouldn't have any of it. It just would not let us have it. Noble try, but not good enough. So it's Xcode really helps you with this. It gives you errors when you try to make a non-escaping closure escape. And one really cool thing about NoEscape is that it gives you extra optimizations behind the scenes at runtime. And also, you don't need to capture self inside of a non-escaping closure. I'll repeat that one more time. You do not have to capture self inside of a non-escaping closure. It's a big deal. I know I get annoyed every single time I have to do that. All right, now we're going to move on to the auto closure attribute. And I know I went pretty fast through that, but there's more to see here. Now, compared to NoEscape, auto closure isn't quite as impressive. So in the function here, we're doing a very simple test to see if our noble Z fighters array contains our beloved character Krillin. What you may notice here is that instead of passing a closure to the assert function, we're actually just passing a Boolean. And this looks very weird for us because the assert function accepts a closure, but when we call it, we're not actually passing in a closure. This is because auto closure is special. And once you understand what it does, even its name starts to make a lot more sense. So, auto closures automatically wrap your argument in a closure. So, through compiler magic, it can infer your statement as the return value of a non-escaping closure that it creates for you. Now, let me say it again. It creates a non-escaping closure for you. So look at that. NoEscape made just snuck back in there, didn't it? So this is because auto closures automatically apply the @NoEscape attribute to your closure parameter as well. In fact, the code that you see up here is exactly equivalent to this code. And you can kind of see why we would want to use auto closure. This code is a lot of code. Auto closure makes it a lot more simpler. Now, the important thing to remember about auto closure, again, is that an auto closure automatically wraps your argument in a closure. I know I've said that like 3 times, and I hope that helps, but I'll understand if it doesn't. Personally, I had to say it to myself 100 times before I finally got it. But we're going to move on for now, on to simpler and better things. So the next on the docket is inline lazy variables. So you may have seen this code lying around somewhere in your code when you were creating a lazy variable. Now, the crappiest part about lazy variables is they do not look like actual variables. They look like huge functions. And they look super ugly when clustered with other lazy variables. And personally, I don't quite like it. But there is a better way to do it. And this is where inline lazy variables come into play. And it looks a little something like this. So every time I see this, this is how it makes me feel. It's just the best thing in the world. And that's right. You just saw what you just saw. We turned this into that. How does it work? Don't ask me, but I think it's awesome. And honestly, after talking a little bit about auto closures, I think we can make a very decent assumption as to how that actually works. Are there concerns? There are definitely concerns. You may be saying things like, how does it work? I see you had to use self there. I always had to explicitly use unknown self in my lazy variables. Well, never fear. Most of that is already done for you behind the scenes. Inline lazy variables do something very similar to auto closures in that they wrap the right-hand side of the equals operator in a closure for you. However, it does capture self strongly by default. So that is the only warning I have for you. When you use this, remember, it will capture self strongly. Now, knowing that, you have to really pay attention because you want to make sure that you don't get reference cycles. Now, for the sake of showing an example that actually works without creating a reference cycle, here you go. This is the most common use case scenario when we use a lazy variable. And as most of you already know, this is a playground. And it shows that our dinit actually gets called after we set Goku to nil because there is no strong reference cycle here. So for the most part, you can use this very safely. Just make sure you pay attention when you use this and pay attention to your code so that way you don't create a strong reference cycle. But for the most part, for like 90%, you don't have to worry because it works. Now, with that out of the way, I have something else to show you. They're called labeled loops. Now, this one by far excited me the most when I saw them debut somewhere around the time Swift 1.2 came out. Now, there are other languages that already have this feature. So this is not new to the programming world. I believe Java has it. There are a couple of other languages that probably have it as well. But that does not make it any less special. Now, you may have seen code that looks like this. This is a lot of code for one slide. Basically, this function is a very long function that figures out the winner of our epic battle between Majin Buu and Goku. You may notice the stupid Boolean logic that we have in there just to figure out when to break out of both loops. Because, as we know, when you have nested for loops, you could go for a very long time. Now, I've done this logic enough to know that it really bothers me having to use a superfluous Boolean inside there just to prevent my loop from going on too long after I already found what I needed. Now, luckily for us, Swift has labeled loops. And with that, we can have a lot more beautiful code that looks like this instead. No more Booleans. This makes me very happy. As you can see here, I've actually been able to apply a label to both loops. You can see in the first loop, I've applied the enemy fight loop label with a colon and a space and then the regular for loop. And the inner for loop, I've applied the hero fight loop label. Now, once I've looped through all of those loops, and I finally found the attack that finally wins. And of course, as we all know, it has to take about 5 episodes before we finally actually beat a battle. We can finally determine our winner is the hero, and this is where the magic happens. Right there, right below the winner equals hero line is break enemy fight loop. That is so beautiful because you are explicitly telling the program to break the outer loop without having to break the inner loop first and then figure out whether or not you should break the outer loop, and we get rid of Booleans, and it is a lot more readable. So label loops are pretty cool, and as you see here, I've used it for a break statement. But we're not just limited to that. We can also use it for continue statements as well. Hooray for neat control flow. So the next thing is type omission. This is actually a very neat little feature that gets overlooked all the time. I've been on several apps that don't use this when they could to make their code look a lot better. It's very simple, very simple. And in my opinion, it's one of the better uses of type inference. Now, as we all know, there are essentially 3 hair colors in Dragon Ball Z. If a Saiyan turns into a Super Saiyan, his hair turns yellow. If he isn't, then it's black. But there's only one character in the show. His name's Trunks, and he's the only one, and he has purple hair. So 3 hair colors. There you have it. So if we were to write logic to use this function, how would that look like? It would probably look like this. If you're Super Saiyan, change it to yellow. For all other cases, unless you're Trunks, you're purple, but everybody else is black. Now, it's pretty straightforward. It's pretty. It works. You could even say it's Swifty. I mean, you could technically say it's Swifty since you're writing in Swift, but if you do, you'd still be wrong because it's not Swifty. In fact, I'd argue that it's not Swifty until we use type omission. Now check this out. Pay attention to the slide and then look at this. Now that's Swifty. Now you may be wondering, how does that even compile? Where did all the UI colors go? UI color isn't an enum, so how is this even possible? Well, by using type omission, we can actually take advantage of type inference and use our beloved enum sugar syntax on static variables and functions. And I'll repeat that one more time. You can use it on static variables and functions. So there's also one very important thing to remember to make that work. Your static variable or function has to be inside of a class or value type, and it has to return an instance of that class or value type. So let's see how this looks like when we create our own type omission capable function. So as you can see here, we have a determine power level function that is a static function of a power level struct. And it returns an instance of power level. And we also have a helper method called power level is over 9,000 that accepts an instance of power level. Since our static determine power level function returns an instance of power level, and it's a member of the power level struct, we can use type omission and completely omit the need to type out power level every single time we want to use it. Normally, you would use power level dot determine power level and pass in Goku when you want to use that bottom if statement. But because we pass all of the rules for a static function that is a member of a class or value type that returns that class or value type, we can use the determine power level function just like you would use an enum. So this might feel very weird, but it's completely natural because if you really think about it, this is exactly how enums work. Since an enum's case is essentially a static variable inside of an enum, and it returns an instance of that enum, this is why we can use that dot sugar syntax when we work with enums. And this is no different than when we do the same thing here for our static function in there. So basically, to sum up, if your static variable or function behaves exactly like an enum case would, you can omit its type every time you need to use it inside of a parameter. Now, I just want to go and look at this just one more time because it's just so pretty. We have this, and then we have that. As you can see, it's a small change, but sometimes the smallest change can make the difference when making clearer, more readable code. And it reads just like a book. I love when my code reads just like a book. And by the way, if I may say so, you should as well. If you don't love code that reads like a book, then there's probably something wrong with you. But hey, I'm not here to judge. And that's it. Now, by far, this is not an extensive list of cool Swift features that you can use. But for now, it's pretty much all I have time to talk about. I do have an English version of this talk on my website, krakendev.io. If anyone actually wants to, and I'll just leave that up there for all of you guys. If somebody wants to give me a Japanese translation of the blog that you'll find at that URL, I will happily take it and put it on my website so that way all of us can read it and reference it whenever we need to. Arigato.
すいません。So inline lazy a variable part probably I misheard you. And just like an auto closure. So it can perform the wrapping. And after that, so we have to strongly capture the inside of a closure. So in the cases, there is a difference between auto closure and lazy variables, in my understanding. So, did you get my message?
Yes, yes, I did. I'll wait for you to put. Okay, are we good? Okay. So the question was basically, is there a difference between auto closure and inline lazy variables? And there is. And you're right, you probably didn't hear me right. So inline lazy variables, they behave like auto closure, but they aren't auto closure. So that being said, they do capture self strongly by default. But the answer to your question is they are different. They just behave like each other. Is that okay?
So, if that's the case, self.method, I think it's written in your presentation. So self is not captured. So it looks like self is not really capturing self in your examples.
In this slide? So it is capturing self. As you can see, I'm using self there, and that's how it captures it.
Meaning that the self is strongly captured here. Sorry, it doesn't tell me that this is strongly captured. The self here.
Yeah, exactly, and that's why I made a point to talk about. It's not obvious that it captures self strongly, and that's why I said it does capture self strongly by default. I know that I did some tests, and that's just a rule to remember. That is the one backside of the one bad part about using inline lazy variables is that to somebody who reads the code, it's hard to see that it captures self because it's so short. But it does capture self. This is mainly to be used if you have a lot of lazy variables on top of each other and you want to make them look a lot better so that way you can read your code easier.
Thank you.
You're welcome. There's another question here.
In the first part, maybe first or second slide. NoEscape, lazy, all the names lined up. The second slide, I think, is a slide showing, yeah, that one. No, the one before. One before. Yeah, that's one. The lazy, the before, lazy, lazier. What is it?
So that was a typo on my part. Thank you for pointing that out. I will make sure to change that when I upload the slides. When I wrote this, the lazier was meant to indicate that that you can be lazy when writing your lazy variables. So you don't have to write so much boilerplate code. You can just write very small amounts of code. And that's why I said it's a lazy variable. and that's what I was originally going to go with. But technically, I thought it made sense to use inline lazy variable.
はい、わかりました。どうも。
Thank you. It's a great presentation. Learned a lot. Thank you.
Thanks for a great talk. In your example with the labeled loops, I guess you labeled both of the loops. Was there a reason to label both of them?
Actually, yes. It was just to show that you can label as many loops as possible, and you can give them different names, and it's just how the code would look if you were to label both. I didn't actually need the inner loop label, but I wanted to show in this slide that you can do multiple labels throughout multiple for loops that you have nested.
Okay, thank you.
Mm-hmm. It was actually also meant to show that there's a difference between, like, you can see clearly that I'm not breaking the hero fight loop, I'm breaking the enemy fight loop. So.
Hi, Hector. Thanks for a great talk. Regarding the auto closure, thanks. Yeah, so that kind of two-part question. So first of all, if you have auto closure there, that means when you call it, you can still like write a full closure if that's more appropriate for what you're doing. Yes?
Yes.
Right. So, I mean, it seems super useful. Is there any situation where you would advise not to put auto closure on there?
Almost
we always do this.
Almost every situation.
I mean, is there a situation you can't, or?
I mean, there's, depending on the code that you write, you can use it wherever you want. In fact, Apple actually advises against using it liberally throughout your code, because the unfortunate part about it is it reduces readability of your code. As you can see here, actually, if I didn't know what assert was doing, which, as we know, like assert is a standard library function. If I didn't know what assert was doing and I saw somebody calling assert like this, I would assume that the assert function just accepts a Boolean. And that kind of reduces readability, because if you really want to know what's going on with your code, then auto closure just doesn't help very much with that. It's very useful for this because it does, everybody knows what assert is. So it does improve readability a lot when you're writing tests. So you can just like pass in a function that returns a Boolean, and just behind the scenes, it just happens to have an auto closure. But for my everyday use, I have not yet found a reason to use auto closure. But at NoEscape, I have used that everywhere. Auto closure, however, I can't really think of a good example.
Thank you.
Yeah.
Thank you.
Mm-hmm.
Thanks so much, Hector. Great talk.